cloud. Right. So if this fails, which we've already had 2 failures today, we had like 4 failures last night. We are recording this, so we will put the recording on the group as soon as it comes down from Zoom. So we're on Zoom, and so we've already done our introductions. Let's do it really quickly again. I'm Caroline from Bubbly Maths, making maths fun. That's our objective in life. While we can't do it in schools at the moment with workshops and shows, we're doing it online, and the wonderful Lenny Williams is here.
Oh, hello, that's me.
Right. Yes, it is. And Lenny is, so remember, if this cuts off, we're not going to start another live. We're recording it and we'll post it in the group.
Okay.
If you have any questions, please do type them in this one. And if you've got any questions about how to help with if you've got any specific problems that you're experiencing at the moment with your kids, with maths, just post them and we'll find solutions for you. We'll help you as best we can. Over to you, Lenny.
Hi, yeah, I'm Lenny, and I'm an entertaining engineer. And I couldn't say I was one or the other any more than each. I think I'm both. And I like putting shapes together, and I like making people laugh, especially kids. And yes, so I call myself a laugh-o-matician, possibly. And that's it. So I'm here to try and make complicated things simple, so we get enjoyment out of it. It is about making maths fun for kids and kids of all ages. So, and I've stopped growing up, so I'm a kid now as well. So yeah, and I think today, if this is episode 3, it is for me. We were going to talk about how numbers are represented, and or how I represent them, and what do they mean. So it's that kind of thing, and do the symbols relate to what they actually are, so that kind of thing. So playing with numbers, playing with symbols.
Right, let's go.
Oh, let's go.
Let's go.
So
let's go. Because sorry, we did say this the other day that I discovered the first night that we spoke that Lenny does not think about numbers the way I think about numbers. He's actually got his own way of representing numbers. Now, the huge realization for that for me was, although I was aware of the fact that everybody has a different way of visualizing their maths and other things, Lenny really has a huge visual way of doing it. So what we're encouraging you to do is get your children, in fact, you yourself, represent your numbers with pictures and see. Don't look at each other's work.
No. Everybody
separately draw numbers with a picture, some way that you represent numbers, and then come together and compare. And it won't just give you an interesting activity, but also give you a very good insight into how your child sees numbers and works with them. And you can ask all kinds of questions like, why did you do that? Explain this and explain that.
Yeah.
And it just really gives getting them to explain things whenever they have.
Yeah.
You're not sure what they've done. It's very powerful. This is our producer, by the way, the lovely Yvette Franklin.
Hi, Yvette.
Producer. She's hopefully. Oh, and I think we've lost the live. Maybe we haven't. But anyway, I don't.
Should we go? Let's
we're going.
Okay. Right then. Yeah. So to me, the reason I see shapes before I see numbers is I actually think that we unlearn that skill. We unlearn the skill of recognizing shapes. So I honestly believe, and I can't see how it could be any other way, is that before you learn numbers, before you learn counting, you're playing with blocks, and you're playing with a game which has got square pegs and round pegs and triangular pegs, and it doesn't take a toddler long before he starts observing what he's looking at, and he's working out that even though he doesn't know the numbers, this shape, this triangle, has 3 sides, or it has the wrong number of sides compared to the square that I'm trying to put it into. So I think we understand quantity and shape and value before we realize what the numbers are. And then I think we pile on top of that numbering, counting, and all that kind of thing. And then we forget about what we learned before, or we push it to the back, and that becomes less important. So I think we all start to see shapes in the same way, and then we just pile so much more on top of it that it's hidden underneath. And for this is me going back to the roots of what numbering is for, what we needed it for, and ultimately what we can do with it. So we got to the point yesterday where, as if you've got a triangle and a square and a couple of other shapes, you can build anything. So it's that kind of thing. So it's yeah. So basically, I'm going back to, I think, the basics of numbering and value. And
right.
but at the same time, so
it.
you can turn any of this into a game.
Let's do it.
So let's do that. So we'll get rid of our title because I'm going to need this shape.
Aww.
Yeah, I would have liked to have kept it there. Maybe I'll find a way to do that tomorrow. So now, I've got a numbering system. This is the one we all know. We call it 0, 1. This is a decimal system. We don't all use a decimal system. Some people use a sexagesimal system, which is 60. Some people use base 12. It depends on where you are. 6, 5, 6, 7, 8.
Not really. Yeah, not our audience.
Not our audience.
Yeah.
We're sticking with the old decimal.
Some of us coders, back in the day when we used to have to do machine code, we used hexadecimal, didn't we?
Hexadecimal and binary and things like that. But so machines think in hex as such. But anyway, we're not getting that complicated. Right, so these are our numbers. These are the numbers that we got from the Hindu-Arabic culture. They gave us these numbers after we got mixed up with Roman numerals, and they weren't very good for big numbers. So we got these, and we could count much bigger things because we introduced place value, which we're not going to do here, place value, but we've got 10 numbers. The reason we've got 10 numbers is because we've got 10 fingers. Great. So, but I think I can create a better system, because for me, when I think of 1, I just think of a solitary 1, a shape like that. It's just all on its own, a lonesome point. No point to that.
Wait a minute, you missed 0 out.
I had missed 0 out because I'm going through the numbers.
That's okay,
well, I should have put that in. Right, okay. If you just, you're right. I use 0.
You don't. It's blank. It's supposed to be blank.
Well, it's blank, but you can't represent blank without a space. So 0 became our placeholder. Before we had 0, I don't know if you knew
the blank
this.
better. I like blank because the 0 is a number.
Right. So before we had 0, we used to use just a point. Okay, we just use a point as a placeholder.
I want to take that away.
I know.
What we're doing today is not to have a symbol; it's to actually represent every number.
Okay, no, this is giving it value.
I was tongue in cheek when I said that, Lenny. I want to see nothing there. There's a reason why there's nothing there. It's because 0 represents nothing.
Well, it becomes a placeholder. 0 becomes a placeholder when you haven't got anything else to put in there.
Okay.
That's why we have 0.
Yeah.
It does have a value, but only as a placeholder.
But so we're not writing numbers here. We're representing.
So we're using the symbols and we see if they work. So anyway, so
we want nothing there for this.
Yeah, I deliberately missed that out, but if you want it in there, because it doesn't work with the others. So let me carry on, and we'll come back to 0. So 1 is a point. We can see it's 1. It's the only one. So that's 1. That's my symbol for 1, a point. Okay. So we can continue that. If 1 point is 1. 2 points would make a good symbol for 2. Okay, great. It looks like 2. It's got 2 points. It's a line. You don't really need points. You can just draw the line. 3, we could draw as a triangle. We don't have to put the points in, but it just explains what it is. 3 points means 3. Okay. We can have, that could be my symbol for 4. 4 sides, 4 points. Very good. For 5 points in a nice circle, and I just like, because it's nice and quick, to draw a star. So it's just nice. I actually proved there's a better symbol, but there you go. So 5 is just pretty, and this is about beauty as well, because maths very often leads into beauty as well. 6, we started calling it a rectangle, but we've decided this is an oblong. There's a better description for it. So there you are. So this is oblong, and or 2 boxes joined together.
I'm just going to say for the purists that this is actually not an oblong, because it's got. This is for the purists. This is not for young primaries.
You help me with the purists then.
Because it's got 6 nodes. Therefore, it's actually a hexagon.
Oh, okay.
For the purists.
Is it? With a line in the middle.
Well, the line through the yes, all right, but it's about the dots.
I think it's a net, isn't it? But
yeah,
we call
it could be a net. Yeah, it could be a net. Yeah, we'll just debate it. I like it.
We were calling it rectangle. If you're dealing in if you're dealing in Lego, that would be the rectangular one. So that's what most kids would call it. Okay, so we'll call it the rectangle. But we'll
just call it a rectangle.
We'll call it a rectangle because it's nice and easy, and kids get it. And this is really for kids of all ages. 7 is our rectangle. Again, our oblong, except there's a single point that we haven't accounted for, and we put it up top. We create a nice little house with 2 compartments, his and hers. So there we are. So that's 7, and then 8 is basically 2 4s. So it looks like that. Okay, and then 9, we can create a nice pretty symbol like this. 1 2 3. I call it tic-tac-toe, and it's a crossed box with 4 compartments.
This is real life representing how Lenny thinks about numbers. This is how Lenny visualizes numbers. So,
and then
we want to see how each of you visualize your numbers. Please take pictures and put them in the comments to see how you and your family visualize numbers. We'd really love to see it.
That would be nice.
Yeah.
Okay, so that's my symbols. We need something to represent 0, and I haven't found anything better than 0. So it's basically an enclosed space. It does what it says.
It's got no dots. It has no dots.
It's got no points. It's nice and round, so it doesn't actually have a point. And all these have got some point, but that's got no point. So no points.
Yeah,
0 point.
0 point.
That's a nil point. Perfect.
Nil point, thank you.
So we'll call this our Eurovision symbol. This is the score we always get in Eurovision. That's great.
I think we actually got some points last year, didn't we?
Well, yeah, not worth worrying about, I don't think. So there we are. That's my number symbol. And so great. I was really proud of this until Charlie, is my student at the moment, said to me, well, if it's such a brilliant system, he said, what is triangle times square? And I went, oh, right. And actually tried using it in sums, or calculations. So I quickly thought about it, and I came up with this. I drew a triangle, and I put a square on each corner of the triangle. So that's a triangle of squares. And I counted the points. So you had 1 2 3 4 there. You had 1 2 3 4. So this is the square times table. 4 8 12. The answer to triangle times square is 12, or triangle box, you could say. So there you go, which is a triangle. So it's triangle. So so we can manipulate those shapes. There's another way to do that as well. So we could also do it the other way around. We could do square times triangle. Does this work? Let's have a go, see if this one works. So we want a square. Start off with our big square, and we put a triangle on each corner like this. So we've got 1, and we got 2, and we got 3, and this is playing with shapes. And we count the points: 1 2 3 4 5 6 7 8 9 10 11 12. We've got 3 there, we've got 3 there, we've got 3 there. This is our 3 times table, or this is our triangle times table. So 3 6 9 12. The answer is 12. So it works, and it works nicely. Not only does it work nicely, it also looks quite pretty, and it's a game you can play. So if you gave your learner, your student, shapes and asked them to move them around and create groups and create patterns, they could quite easily do that. So it is a game, and it makes sense, and it says what it is as you're going along. It explains itself, and it really explains what multiplication is. Multiplication is groups of, equal groups of.
And so you can make manipulables at home, as in you can make the pieces at home just by cutting out bits of card.
Cutting out nice coloured bits of card. Yeah. Why not have different colours for each shape?
And you can literally move them around and
put your points.
And work out
So
really get a feel for multiplication, for example.
And you can, you're always going to be counting with your child, but you don't necessarily need to say we're going to learn multiplication. That isn't at that stage.
Oh no, you don't mention, you don't name it.
You don't need to say no, because it's this is about learning to hug numbers. So it's get a
warm and fuzzy feeling about numbers.
Get a warm and fuzzy feeling. So you love numbers before you get to the point before things get complicated. So there you are. So that's really what. So I think that works quite nicely for my symbols. So my symbol hasn't broken. So I think it works, and it sort of works for division. So you can do it backwards. You start with your shapes and put your points out, and then you can say how do I divide it into groups. It does kind of work. Right, okay. So I thought, there you go. I've got an unbreakable system. I know it works. And if it works for multiplication and division, surely it's going to work for addition. Okay, let's try it. Let's just try and add 2 of these. We haven't done that before. Went straight to multiplication. So what I did was I picked 2 plus 4. Okay.
So our challenge to our viewers now is going to be, can you please break Lenny's system?
Can you break the system?
See if you can break the system. That is a way of doing a mathematical proof. It's part of the process of doing a mathematical proof. Doing a mathematical proof, you are looking to break the system. And if
looking to break the system. Well, I broke my system almost the first time. So, so that's my symbol for 2. Okay, and that's what it just looked quite nice. And so 2 plus 4. Okay, so this is all about manipulating the shapes or the numbers, and playing with the numbers. So what I did was I put my 4 down first, like this, and then I put my 2 down. But it didn't look like anything I've already got in my symbols. So what I thought, I think I know what I'm doing wrong. What I need to do is turn my number 2, my line, on its side. And now what you've got is you've got 4 dots next to 2 dots. Well, that is the same as this. So literally it's 3 2s. So all I've done is I've just gotten rid of the points for a second, all the points, and I've represented it there. So what I've done here is I've turned my symbol.
Okay.
So I've turned my symbol on its side. So I've not broken the system, but I've bent my system.
Yeah, so, you haven't bent it at all. You haven't bent it at all. No, the number hasn't changed. It still represents 2. It's just been rotated.
That's right. So
you haven't changed the value of the number at all.
No, I haven't broken it, but I have bent it. I've literally turned that. I've forced that round. So now
that's not bending it. So you rotated it. You haven't bent it.
Okay. So what I'm saying is I've allowed a little bit of flexibility in my system. So now I've got 2 symbols.
Flexibility is the key, and it's beautiful.
That is the whole point. So now what I've introduced is a new rule I didn't have before, which is you're allowed to rotate my symbols. So I've introduced a rule to account for this. So there we go.
Hold on, Lenny, don't move on yet. There's another way you could have done it. You could have put the 2 on top of the square.
I could have done that. But then I would. Yes, I could have done that. But that wouldn't have looked like 6.
No, it would.
That wouldn't look like. So if we're sticking with,
that's critical, Lenny. I disagree with you there.
No.
We're gonna have one of our fisticuffs.
No. Listen. Right. Okay. This is how it works. These are my original symbols, and what I said was these are my symbols, meaning I can't do anything. Meaning I can't change my symbols. These are my symbols. I didn't say before anything about turning them. So if those are my symbols.
But we're rotating 6 now. So
I know, but I didn't. Yeah, but you can't write the number 2 like that. That doesn't mean 2.
No, but that's the whole point of what we're doing, Lenny.
There you go. So
by symbolizing, by representing numbers with.
So I've got a number system, but I've got some different rules. There are some different rules. So what we're doing is we're manipulating the shapes. We're talking about shapes, so we're not talking about numbers. So we're playing with the symbols, which is really what this is all about. So I've allowed a slight flexibility in the rules in that you're allowed to, so to make this work, I'm allowed to rotate that. So I've rotated that. I could have rotated the square, put it on top, but I want it to look.
I'd really love to prefer to hear you say that it's not slight flexibility, that there's one rule, and that is rule is that you must have 2 dots with every 2, 3 dots with every 3, 4 dots with every 4.
Okay,
apart from that.
No, right, okay, you've got to allow this flexibility to rotate things, otherwise you don't end up with a symbol. So you've got to say, although we've got these symbols, you are allowed to rotate them. When you talk about this system, Caroline, you say that. So now listen, this is where we end up. So we end up with this system here.
We're not breaking the rule. It's the language that you use.
No, I didn't say we broke it. I said we bend it. We bend the rules.
Bending.
Let me carry on. Let me carry on and finish.
Yeah,
Let me carry on.
I'll stop arguing.
So there we go. So we got 1. So that tells us we got 3 groups of 2, which just happens to work within 6. That is a rule of 6. We've also got a group of 1, 4 and 1, 2. So it's actually telling us these are just symbols. They're actually symbols. Effectively they're numbers, but they're actually telling us what they are and what they stand for as well. So that stands for 4, that stands for 2, and nice. And then if you just join those, we've created our 6 symbol. We've created our 6 symbol. So it's just come out of the fact that we...
I really have to go back to the business about rotating it, because if you rotate the 6, it has the same
But we never
value.
said before that you were allowed to change the 6. So 6 can't be...
And it's a realisation.
There's a realisation that...
6, but there's nothing...
Caroline, listen.
Yeah.
You have to allow flexibility within the system. You don't have flexibility with the old number system. So with my system, you've got to say that you're allowed to rotate numbers. Even if you say you're allowed to rotate the 6, they didn't know that before. So now we're saying...
No, but we're not allowed to rotate the 6. When we write a 6, we have to write
we're not allowed
that way up.
That's
we're
exactly
writing.
what I said. That's exactly what I said.
Yes, but Lenny, no, this is really important. Lenny, please, this is really important.
Yeah.
Because children, when they see a square and it's rotated, they don't think it's a square, they think it's a different shape.
I know that.
Since you're using shapes, it is the same shape. It doesn't matter which way round it is. Whereas,
I know. But a 9 isn't a 9 on its side.
Whereas, if you write the number 6, it must be the right way up, or else...
That's right. That's right. So when I start with my system, I say, these are my symbols. At no point did I say you're allowed to rotate them. I just said they're symbols. So that wasn't in the original description.
But it's a realisation that you can.
No, right, okay. So when I start with my system...
Whereas you can't rotate the numbers because it
still goes back to when I started, I did not say you were allowed to rotate these symbols. So now I've had to say, to make this work, this symbol system work, this square system, the system of points or shapes, you're allowed to turn the shapes around, which is what you're allowed to do in real life.
Yeah.
So that's it. So yes, you're right that you could have put that 2 above that square and made 6, but I didn't say you were allowed to turn the 6. So now what I'm saying is you can rotate my symbols, so you can do it this way, or you can create that. So they both work. So now I've created a new rule that makes my system still work. So it makes it still beautiful. So just this flexibility. There are other flexibilities now that I've also got to introduce. So there we go. So if I'm allowed to turn that 2, then I'll put it on its side and I'll join it to the square, and that creates that symbol, and that symbol is a 6.
Yeah.
It doesn't matter which way around you turn it, because now we're allowed to turn. So it works for that. And let's see if it works for something else. So I'm going to try something else. Okay, let's give it a go. I don't know what time we're on at the moment.
We're 33 minutes.
33 minutes?
Yeah, 8:33.
So let me try this. This is a new one. 3 plus 4. Okay, so 3. What's 3 in my symbol system?
Triangle.
Triangle. So triangle. And what's 4 in my system?
A square.
A square. Okay. So I'll put down where we're trying to end up. This is what I'm trying to end up with. Okay, so that's my symbol for 7. Can you see that? Is that clear enough there?
Yeah.
Okay. And I want to get from here to there. Right. So, where is there a triangle in this shape? I can see one. Okay. There's a triangle there. Okay. All right. So admittedly,
and it's not an equilateral triangle, and that's
not an equilateral triangle.
And it
so,
doesn't matter what shape the triangle is.
No, that's right.
Because it's still got 3 vertices.
You're absolutely right. So I called this triangle. I didn't say it was an equilateral triangle. Phew. Yeah. I'm glad I didn't, because because it would have broke my system. It hasn't broken my system. So there you go. So perfect. Okay. So I've found my triangle. Where's my square? Can you see a square? Oh, right. Hold on. We stopped calling it a square.
Can you do what we do with algebra? Can you do the next stage? So we have an equals, and then can you rotate so that you actually see the shapes? And then
so this is how I resolved it. I had a look, and I thought, wait a minute, we've got 4 points left. What if I join them? 1, 2, 3, 4, and right. So there is my 4-sided figure, which is a squarish. So squarish. That's good enough for me. It's in the right place, and we're only using that point once. That slightly misses it, which is why I quickly dropped it while you weren't looking. And we've got that symbol.
Well, it's an equilateral, quadrilateral, isn't it?
It could
doesn't
still
actually matter whether it's it's completely irregular. So, none of the angles are the same. It's a quadrilateral. It has 4 points.
And it's larger than we started with, but okay, that's another flexibility I'm allowing in the system. You can make the square as large as you want, or you can rotate the square. So you're allowed to do it, and you don't have to be absolutely precise with your shape as long as it's recognizable. So
as long as it has 7 points.
As long as it has 7 points. So what I'm going to do,
and if it's got a pattern, then it helps us recognize.
It's got a pattern. So I'm going to do this then. So let's see if this works. So I'm just going to rub out. So I've got the end. So now I know where I need to end up now, and I know how to get there. So this is all about 3 plus 4. So here is my 3, and here is my 4. Okay, so I've just moved things around, and if I redraw the points, 1, 2, 3, 1, 2, 3, and 1, 2, 3, 4. So 1. Sorry. All right. So there's there. Right.
There's a triangle.
Go back a step. Sorry. I jumped a bit. So I should have drawn the triangle in first. Yes. Sorry. I did that slightly wrong.
So we don't.
So here we go. Triangle first.
Right. The vertices of the triangle.
There you go. Sorry. The vertices. Yeah. There's my triangle. I'm not going to draw the lines, and then I'm going to do my square, which is turned on its side. It's squarish or 4-sided, and so that's going to. But I'm going to join these differently. So that's the top of my square, you could say. And there's, so what I'm going to do, I'm just joining them the neatest way. And I've ended up with my 7 symbol.
Yeah.
And I've still got the same points in pretty much the same place. So that's my symbol for 7. And that is 7. That's my symbol for 4. Excuse me. That's 4. And down here is the 3. So it's 4 plus 3. 4 plus 3 equals 7. So the symbols are saying what they are. You manipulate them. You can put them back in to the final. So once you've learned this system, you just say, right, I'll get that 4. I'll turn it on its side. I'll plonk it on top of the triangle. Maybe make it a little bit bigger. I can fit it in there. So, and we end up with 5. So it works for that system. So
it works. Perfect. Yeah, it works for some numbers. It'd be interesting to see what 5 plus 8 and 9 plus 8. I mean.
So, right. So
9
so
plus
we're
5.
going to stay with numbers that add up to less than 10.
Right.
Because there's other reasons. So what did I do there? So I've literally said we can rotate this symbol. Okay. So that's a new symbol. So it's it's the same symbol.
I was going to say, it's not a new symbol. It's the same
it's
symbol.
It's the same
just
symbol turned.
rotated.
But because I allowed myself to rotate it by 90 degrees, I'm now saying you can rotate it by 45 degrees as well.
But you also distorted it, so that was a different symbol, but it still had an equilateral. It was an equilateral, quadrilateral.
That's right. And this one here,
it was all squished up and stuff, but it's still a triangle.
Flattened it. I flattened the curve, which we're all trying to do at the moment. So, so I could always draw a symbol like that. It doesn't always work. So basically, you can have a normal triangle or a flat triangle. So we're ending up with alternate versions of our original symbol. So great, it works for that. Okay, can I break my system? I'm going to try and break my system. 5 plus, I can't remember what I use. I think I use 5 plus 4. 5 plus 4 makes 9. Yeah, okay. 5 plus 4. Let's draw the symbols down here. So
this is a nice way of helping children be able to visualize and understand numbers that add up to 9 or less. That's
effectively it, and playing at the same time.
And playing.
Playing with shapes. I think you could probably put something like this onto create a video, an iPad game or something like that. So if you were allowed to move the points and the sides, but you kept the same shape or the same number of sides, you could probably create all these shapes. So what we're saying is that's a 5-sided figure, which is what it is. It crosses, admittedly. That's a 4-sided figure. So there's your 5 and there's your 4. So, okay, now, where am I trying to get to? So I'm trying to get to tic-tac-toe over here. So not knowing how to do it, I'm looking for a square or a 4-sided figure.
It's a nice puzzle to work out how you combine those two to get the tic-tac-toe. It's nice.
I'll help you by doing this.
I think we should leave that as a challenge for them.
No, I want to resolve it because it drove me mad. It drove me mad.
Right, okay, fair enough.
And I had to go down, have a cup of tea and think about it.
Now, thank you for that, Lenny. That is a really good tip, is that when you're, let's say, solving a puzzle, you know, when you get the puzzles for Christmas, those little wooden puzzles, and you have to put it in, you take it off and then you can't get it back in again, or you put it in and you can't get it back out again. The way to solve those is perseverance and determination. And
that's it.
When you're helping your children with problems, and if even none of you can work out how to do it,
no,
take a break, go away, do something completely different, come back later, come back the next day. That is really critical. So basically, it allows your subconscious to keep working on the problem. And then you come back and you can have another go, like when you're playing chess or solving a crossword puzzle and doing anagrams, that sort of thing. Go away,
and come at it from a different angle.
And then it's amazing how I've come back. I like my word games, and I'll come back and I'll immediately see something. Maybe it might not be the second visit, it might not be the third visit, but sooner or later I'll go, boom, there's that word. Why didn't I see it before? Doesn't matter.
Okay, but look, you're avoiding this. This is what you're trying to do.
I am not avoiding this. This is a very important point. We're here to help the parents, not show off how we've solved it.
Right, so
honestly.
So shall I tell you how I solved it?
You can see me and Lenny have we argue. Put them up.
Right. Okay, if I don't earn a cup of tea for this, then I never will. So
put the kettle on.
Put the kettle on. Now, so I've got 5 points, but they don't look like my star.
They do not.
They do not. But
they're like an inside-out star.
Yeah, they are. And I could create, and Sue did it. This is what Sue did. Okay, so she had those last 4 points, 5 points there, and she said, I've got
to do another interrupt now. So we've got the family getting involved.
Oh, yeah.
It wasn't just Lenny working on it. Sue was having a go as well.
Yeah. So
and you can do that too at home. Get everybody to have a go.
That's it. That was Sue's answer. She said, that's a star. And I said, I don't think you'd call that a star. So it's as close as you're going to get with that. So I started to think, what are the point of my symbols anyway? So what are they meant to do? So they're just meant to represent the value of what they are. So all I need to do, if I throw everything else away, forget about my star, because I love my star, but I'm going to have to give up on my star because that's what's holding me up, is the fact that they're all tied together.
Oh, we've got another analogy there. If an idea isn't working, don't hold on to it. Let it go and allow yourself to think of something else. So, you see, look, Jenny, you're full of gems today.
Well, good, because what it was I was holding on to the unnecessary, and I was left with the essential. And the essential is 5 points. 5
Someone
points.
writing this down. He was holding on to the unnecessary, let go of the unnecessary, and was left with the essentials. And the essentials
okay, so what I said to myself was, I just need my 5 points. That's really, and I only drew that because it looked nice, and it works for multiplication, but that probably would be more in keeping with the other symbols, if you like, because they're all sort of open and enclosed. What I spotted, and this was my moment of revelation, and that didn't look anything like this. Okay, although I noticed a similarity, that there were at least 3 sides that looked similar.
Yeah.
Okay, so what I was holding on to was this top point here.
Yep.
So what I can do is I can drop that point down there. So what I can do, hold on, wait a minute, this is where it's starting to work. I think I know what's going on there. So I got rid of the unnecessary, and I kept my 4 sides. And all I did, I thought of that as 2 different people standing opposite each other, holding their child aloft. So they throw the child up in the air, and then they let it drop, and they hold it down there. So what I ended up doing is, so what I've done here is I've created, look, 1,
so is
2.
That a pentagon?
It doesn't have to be. Well, that's the bit I had to let go of.
No, but it is a pentagon.
Yeah.
You had to let go of. No, this is beautiful, Lenny. This is really beautiful.
I think it's still a pentagon.
Yes, it is. One of the really the beautiful thing about what's happening here is this isn't just about numbers. What you're talking about is you're helping children play with shapes. And the thing is that the top one, the middle one, that looks like our normal pentagon, is sitting on its bottom, nice and horizontal. And that a lot of children believe that if it isn't drawn like that, and it's regular, all the edges are the same, all the angles are the same, if it isn't drawn like that, it's not a pentagon. But it's absolutely not true.
Is that still a pentagon?
It's just as much a pentagon as the other one. It's just not.
No, I wasn't sure about that.
Absolutely a pentagon.
I didn't have long enough, because I was dancing around the house for so long after this. I lost all time.
But you had that revelation. It's beautiful. And this is the thing, that you're turning squares on their side. You're rotating squares. You're having straight lines that are moving around. You're squishing triangles. These are all still. That is still a square. It's still a triangle. It's still a pentagon. It's got 5 sides. The definition of a pentagon or any polygon.
Yeah.
Oh no, I've got it. You know, you were doing jokes yesterday. It's my turn now. You ready?
Go on, then.
What is the definition of a polygon?
I don't know. What is the definition of a polygon?
It's an empty parrot cage.
Brilliant. That's
for those that haven't got it, because now I have experience with this joke. Most, especially kids, just go, huh? What are you on about? Are you?
Where's polygon?
Kind of where has polygon? Polly's a parrot. Polly's not in the cage, therefore polygon. But the official.
Oh, even she gets it. Oh, she's not even listening. Well done, Yvette.
Okay, so.
Some jokes you do need to explain.
So the thing is, polygon means many. Poly means many. It's ancient.
Poly means many. Gon means
and
knees.
Gon means and elbow. It means I finally got to the root cause of it. It's joint. It means joint.
Number of joints. That's right.
Joint. So polygon is many joints.
Yeah, many joints.
Polygon, the definition.
Well, how many joints have I got?
Shh, we haven't got there yet. The definition, the definition of a polygon is a closed 2D shape with straight edges.
Oh.
So closed means joins together. If you join them together, the pen never stops. You can keep going round. So is it closed?
It's closed. There's no way getting out of there.
Are the edges straight?
Fairly.
Well, yeah. Well, we have to.
Because of my wobbly hand, not exactly, but yeah, pretty much.
They're supposed to be.
Let's call them straight.
Closed, 2D shape with straight. Is it 2D?
Yeah, it's 2D. Flat. It's on the flat
You can cut it out of a piece of paper. It's flat. Okay, that's a polygon.
That's a polygon. Hello, polygon. It even looks like a parrot on its side.
It kind of does, doesn't it? A parrot's beak or something. Yeah. So
oh, there's Polly in the middle.
There's Polly. So therefore, it's a polygon. So how many sides has it got? That's the last thing we do.
So it's got 5 sides.
5 sides. So in ancient Greek, 5 is pentas, and so it's a pentagon. It's got 5 sides, and it's a closed 2D shape with straight edges. So you have indeed discovered a way of drawing a pentagon, and you can use that for your lovely system of.
Okay. So what I had to do then was I had to
9 or less.
I had to slightly bend my system. Well, I didn't. I had to just recreate a symbol. I had to work out what I needed. I needed a polygon, so of some description, and I've worked out that I'm allowed alternate symbols. So that means 5 and that means 5. We could actually lose our star, which would be cool.
I love the star.
I love my star. So I'm going to keep my star.
Yes.
In the same way that we've got 2 ways of writing 7. And you've got different ways of writing 4, haven't you? You can write 4 as that, or you can write 4 as that. So, so I'm going to say, that's it. That's all I'm doing. I'm following the old system, which was there all the time. I'm allowed to create alternate versions.
Love it.
Slightly change the shape.
Love it.
So there you go. So it works both ways. So you can use that, or you can use that if you can find it. So let's get rid of it all.
So let's get creative with shapes and dots. Make sure you've got the right amount of dots.
You've got the right amount of dots. So let's do it again.
Wonderful.
So now what I've got is I've got this. So I've got, it could be this. No, wait a minute. Sorry, I'm going to change it because we're going to turn it by 45 degrees. And we're going to do this. So we're going to use our, are we allowed to call this a diamond? No.
No.
Okay, I didn't call it a diamond.
Diamond is not a word in the language of mathematics.
Okay.
It's a quadrilateral. It's a quadrilateral.
I didn't call it. That was lucky.
You
Okay.
didn't even mention that word.
No.
It's actually not a word. Okay, I've got
it.
another little thing, right? Did you know that children in Denmark don't have to say please?
They don't have what?
Don't have to say please. The reason they don't have to say please is there is no word for please in the Danish language. So what
that
they
sounds
do
quite
have
rude.
to say, no, not at all. They have to be very polite. They have to say, would you be so kind?
And forget, do you know, I say that rather than please. Yeah.
It's lovely.
So what's the magic word? There isn't one.
Well, you have to ask nicely. There is no magic word. You have to ask nicely.
Okay.
But the point is...
Well, that makes things easier for me because at all of my parties, I always ask the children, what's the magic word? And I hope they say abracadabra.
So kind?
Yeah. Well, yeah. In this country, if I say what's the magic word, they'll either say abracadabra or please. Yeah. Obviously, we go to Holland. Is that
Denmark?
Denmark. Sorry, geography is not my strongest point, and that's what I'll get. It's what's the magic word? Would you be so kind? In obviously that accent. So we're really racing along here, aren't we?
No, we are. So no, so the point is that it's that there is no word for diamond in the language of mathematics because the language of mathematics has to be very precise.
Okay.
And if
I'm not going to fight you over it.
Good, because the diamond can represent many. Yes, you would.
And I've learned that.
No, the language of mathematics has to be very precise, and a diamond represents many different shapes. Just think about the amount of different shapes you can wear on your ring or your nose or your ears or your wherever you wear diamonds these days, your tooth. There are many different shapes. They're wearing them on stick. So many different shapes. Diamond is not a valid word in the language of mathematics.
What should I call this?
You can call it a quadrilateral.
A quadrilateral.
You can call it a rhombus if you're talking to little people. You can call it a rhombus, and because we're not quite sure if it's a square, but if it is actually a square and it's just on its side.
Can I just call it?
It is a square. It is.
I'm going to call it a square.
Lovely.
Turned around.
Yes, square turned round.
Yeah. So we turned our square around. So we keep it square because we don't want it to be oblong. We don't want it to be longer than it is short. We want it to be fairly square. Okay, so come on, and there's my 9 points. We want to get there. 1, 2.
Yeah, that's a square in the centre there.
4, 5, 6. So I want to end up with my tic-tac-toe, but it's going to be slightly distorted, but it's still going to be pretty. That's the best thing.
Oh,
so,
we want it pretty.
We do want it pretty.
It doesn't have to be distorted, Lenny.
So you talk me through.
Lenny, it doesn't have to be distorted.
No, it's not distorted.
No, you just make that square just a bit bigger, and that it is a perfect square.
Okay, so talk me through this.
The edges will be different. Yeah.
So talk me through this. So what should I do? We'll call this. Yeah. So you tell me where to start.
Put the dots in exactly the same place as you have them with the tic-tac-toe.
So that's what I've got. I don't know. Perhaps you can't see it.
Yeah, I know, but you said it's distorted. It's not.
No, that's okay. All right then. So I want to draw this in. Where can I put this?
Well, you're going to put it in exactly where it is and joining those four green ones. But you have made that ever so slightly smaller. But the point is, you don't have to make it. But you don't have to. But you don't have to.
No, what I don't want to do is draw my line over the points because the points if they're sitting on the line. You've done it
on purpose. Okay,
I've done it on purpose,
ready.
And there's a reason for it. This is the reason because I don't want the point to be used twice. That's the point. So the point is, I don't want the point.
The point is, you don't want the point to be used twice.
I don't want the point. I should have drawn that in red. So
it's fine. We can see it. It's very clear.
You can see it. Okay. So what we've got 1, 2, 3, 4, 5. That's our 5-sided figure.
Yeah.
And then we've got 1, 2, 3, 4, and that's our 4-sided figure. Okay. And I could have expanded the square, or I could have contracted. I could have done either. So I could have gone outside or inside. This actually looks slightly prettier. You'll see. So
I love
green.
It. I think it's gorgeous.
Yeah, it is in the end. 3.
No, it's gorgeous now.
This is I'll do that in red. So that's, I did that wrong. Sorry. So green is 4.
Oh, okay. That's all right. I was confused there for a minute.
Yeah. And this is 5. Okay. And I'm going to draw those points in exactly the same shape. Here, 1, 2. So the 4-sided figure is just fractionally smaller than the 5-pointed figure. Or the 5-sided figure. And all I'm going to do now is I'm just going to join those.
Yeah, the 5-sided figure has 5 points. That's good.
That's it. 5-sided figure is 5 points. And I'm just going to join these now just to create another nice shape. And I'm going to join that. And, oh, hello. So
it's a distorted.
It's a slightly distorted, but I lost my star up here. But where I've lost, I've gained. I've got a new star. So
you got a star. Yeah.
I've got my star there, and I've
so your 9 can also be a star.
So what I've decided I'm allowed to do is, and I might be cheating the system slightly.
I don't see what system. It's your system. You can't cheat it. As long as the numbers work. As long as you're not breaking the numbers.
I'm not breaking the numbers.
The value of the numbers is correct. Your system is as valid as any other.
So what I'm saying now is the most important thing is to have the right number of points.
Yeah, absolutely.
Not necessarily the right number of sides. Okay, so
no, because the sides there may be a correlation with the sides, but no, there's lots of different shapes you can make there. It is about the number of points. That's a very beautiful point, Lenny. It's all a point. See, it's a point, Lenny.
That's the point of the system.
About the number of dots. not about the number of sides at all. It's not about the number of sides. We're using those to describe the shapes, but it is about the number of dots. And
so what I decided I was allowed to do
to make it pretty and beautiful.
That's right. So I wanted to make it pretty. So I decided I was allowed to have slight curves.
You've got to do it. Us too.
So what we got then? So what we've ended up with is 2 versions of 2, which is the same, just rotated. I've got 2 versions of 3, or triangle, which is the squash version of the original, but I could always use that one if I wanted.
But wait, no, I want to do something else. I want you to now rotate the bottom one by 90 degrees, please.
This?
Yeah. Rotate that one.
I think I can do that.
Yeah, you can. You can do it. The squished one.
Squished one?
Yeah, oh, even better. Yeah,
does that work?
Fine. Either one. Yeah, the point is, it doesn't matter which way round it is, as long as it has the same number of dots.
Well, if you're going to cut these shapes out, you've got your box of 3s. Your box of 3s will have regular triangles, regular triangle, and or squished ones. So that's in your box of 3s.
Yeah.
So you can take any one of those out of your toolbox, and it doesn't matter how they sit in the box, because they're going to rotate as soon as you bring them out. And you've got these.
Bearing in mind that when you're making the 9 at the bottom with the square and the different shape and pentagon, that you might want to draw those rather than, or you could cut them out, those shapes, but you'd have to work it out by drawing rather than manipulating shapes, because you won't actually have that shape until you realise that shape is useful to you.
No. So I've just slightly adjusted my system. I've created some rules that will help my system to work. So the rules that you can't use in a normal numbering system, but we're talking about shapes, and thing about shapes is you can do anything with a shape. You can change a shape slightly, you can move a shape, and it works, and it keeps my system working. So I haven't gone through the whole.
The important rule here is the one you said. That is the rule, that you must have the right amount of dots. Everything
You've got to have the
else
right
is
amount of
flexible.
dots.
It's all about creativity, coming up with your own ideas to help you for a child, but to manipulate numbers between 1 and 9. And then if you're multiplying, you can go bigger, because you're then doing it in groups of numbers.
That's it. So you can move
to help a child to really get fluent, get a nice sense of the value of the numbers rather than the symbol that represents.
That's right. So all of these symbols, they display what my original intention was, and that's to tell you what they are by showing you how many points they got.
Lovely. It's beautiful.
So I had to let go of my star, because even though it was beautiful, it was getting in the way. It works for some things, it works for multiplication, it doesn't work so well for addition. And all I've just come back to is what I need to do originally is have a 5-sided figure, a pentagon. And in effect, the angles aren't so important. So the angles, so it's more, what's more important is that you've got 5 points, which are joined by relatively straight lines. So you can change the angles to fit. So they fit into the shapes, and it works for that. I think it works for everything. I'll probably go through all the possible versions of adding up to numbers less than 10 and see how that works. But I can't see.
Somebody else could come up with a different symbols for 7, symbols for 8, as long as the number of dots are the same, or that you've got the number the shape represents.
That's right.
The number and the quantity, not the number, because the number could be seen as a symbol. Number 4 is the quantity, and that is what matters. It's the value of the number is what it's all about. That's brilliant. I think we better stop for tonight.
If you're happy, I'm happy.
Yeah, that was beautiful. That was really beautiful, Lenny.
Thank you. I hope it was fun.
I enjoyed it. I'm hoping that Yvette enjoyed the polygon.
She enjoyed your joke.
The banter and the polygon. Yvette enjoyed the banter and the polygon joke. So if Yvette enjoyed it, hopefully some of our viewers will also enjoy it. Unfortunately, it didn't go live, so we're going to put it up.
Record it and play it again later.
Recorded,
So I'm encouraging you to play. So screenshot these, create your own shapes, play around with them, cut them out in cardboard, and see what you can do. Perhaps you can show me something that I haven't done. So
Brilliant.
there we
Yes,
are.
and please come up with questions. Show us the shapes that you've made. Show us the symbols that you've created, and please do join the group if you haven't already. Tell other people.
I know what the biggest question will be is what is the point of it, and that's a bit like saying what is the point of playing.
What is the point of it? I love you. That's true. And what is the point of playing? What is the point of playing maths? You know what? The
that's
best way to do maths is by playing it. So the point of it is to enjoy life and enjoy everything we have to do.
So why do we play? Because it's fun. That's literally why we play. And
the key is to make maths fun, and that's what we're here to help you do with your children. So thank you. So we'll just say, please do join the group, tell other people all about it, get other people to join the group. We're also on YouTube, and it's called Bubbly Maths, and there's also Maths Toys on YouTube. So we'll be putting links in. Please subscribe to those as well. Thank you, everybody. Thank you, Lenny. See you again next time. Thank you so much. 8 o'clock every night while the duration, and
have fun. Hug a number.
Yeah.
And let us know when your children end up becoming engineers and mathematicians. And problem solvers.
Yeah.
That's it.
Thank you.
Thank you. Bye-bye.